So this problem is also related to shear force or the shear stress, okay, due to viscosity. A thin plate is placed horizontally in the gap filled with viscous oil and pulled with constant velocity of 0.1 meter per second. The ratio of shear force on upper to lower side of the plate, okay, so we have four options being given, so we need to check so which is going to be right. So now, so when the plate is being pulled, so this is the plate, okay, at velocity v, so you have the shear force or the shear stress which is developed at both the sides of the plate. So this shear stress on the top we'll call this as, and bottom will represent as B. Okay. So now this shear force on the top, okay, this is also opposing and to the moment of the plate. So this will call this as Fu is shear stress on the upper side of the plate. So into AU. So AU is the what? So AU, it is the area, okay, area of the top surface of plate which is being in contact with the what? So fluid. Similarly, bottom we'll call this as AB. Okay, so this is FB is given by shear stress at the bottom of the plate into AB. So but in this particular case, so both AU as well as AB are same. Okay, so bottom and the top face, so both are of same dimension. Okay, so now, so we'll check, so DU, so because so we require, this is given by what? Shear stress is given by, so du by, so dy, okay, so into mu. So we'll check du, so this is what? So du for upper plate, so this is going to be, so velocity of the plate, so that is 0.1, so minus, so velocity at the bottom, so here u is going to be 0, or velocity at what boundary is going to be 0, bottom as well as top, it is going to be 0, so minus 0, so this is going to be 0.1. Similarly, du for, so this side, so it is going to be B, so this is also 0.1 minus what? 0, so this is also 0.1. Okay, whereas dy, so dy for upper one, so this is what? So for upper we'll measure from this, so y is going to be in this direction, so dy is going to be, for upper it is going to be, so 0 for sorry, it is 4, so minus 0, so that is 4 minus 0, it is 4 into 10 to the power of minus 2. Okay, similarly dy for bottom, so it is going to be what? So 1 minus 0, so it is 1 into, so 10 to the power of minus 2, so this is 1 and 2, so Fu divided by, okay, so 1 and 2, Fu divided by Fb is what is being asked. Okay, so that is what the ratio of shear force on upper to bottom side, Fu by Fb. Okay, so this is U divided by Ab. So luckily this is going to cancel here, so it is going to reduce some computations further. So this is going to be what? So we put it, this equation, we'll check this equation, so this is going to be equal to, so mu into, so du by dy upper divided by, so mu into, so du by, so dy bottom. So this is also cancelled because it is the same fluid which is being what? On the both the sides. Okay, so now, so Fu by Fb, so is going to be So this is going to be 0.1 divided by 4 into 10 to the power of minus 2. So divided by, so dy for upper this thing, it is going to be 4 into 10 to the power of minus 2. So here it is going to be 0.1 divided by 1 into 10 to the power of minus 2. So this is also cancelling, so this is also cancelling. So what is going to remain is 1 by 4. Okay, so I think this option is there.